Greetings, everyone, and welcome to Who Are We? The Demographics of U.S. Amateur Radio Licensees. My name is Michelle Thompson, W5NYV. I am an engineer with a master's degree in information theory from the University of Southern California. I'm the co-founder and CEO of Open Research Institute, and I am a telecommunications industry professional. We're going to talk about a problem, defense of it being a problem, a solution proposal. We're going to walk through the code written to address the problem, discuss the results, and talk about a few of the next steps we can take. So what is the problem? We do not have demographic data and information for U.S. amateur radio licensees. Peter Drucker is a name that is probably familiar to those of you in management. He's responsible for the concept of you can't manage what you can't measure. He went beyond this very pithy saying in his writings. You can't know whether or not you are successful unless success is defined and kept track of. You can't improve what you cannot or will not measure. What have we done so far with U.S. ham demographics? Well, mostly nothing. We have the impression that amateur radio in the United States is almost completely dominated by older white men. For a telecommunications service that is supposed to be accessible to, serve, and enhance the communication skills of the general public, not really knowing who we are is problematic. So are the impressions wrong or right? The pain points are numerous. The lack of diverse participation in a fun and easy technical entry path objectively harms our technical workforce readiness in the United States. In the era of STEM, exclusion has real economic and national security implications, not to mention personal ones. Prior work. There is a good study from 2005 about gender by Ken Harker, W5R, called A Look at the Numbers. For all amateurs in the FCC database in 2005, he found that 13.6% were female and 77.94% were male. A number had first names that led to a classification of uncertain, at 8.46%. He adjusted the percentages and estimated that the amateur radio population in the United States at that time was 14.85% female and 85.15% male. This was a slightly higher female percentage than the ARRL surveys indicated, and almost 3 times as high as the percentage of ARRL members who were women. Remember these numbers. Kai Suiak, KE4PT, is the editor of QEX, among many other duties, at ARRL. His editorial from May-June 2018 issue of QEX has some demographic information about QEX subscribers. 90% are older than 61. Half of that 90% is older than 70. 2/3 were retired. 9% were between 51 and 60 years old. He made a very clear call here in this editorial for all hands on deck to address age diversity in the QEX subscription base. He acknowledged that the term Elmer is problematic. There is a good study from 2021 about demographics and CW contesting. It shows what appears to be a linear mapping of time passing to age distribution in CW and phone contesting. If you have not read this article, please do. The Royal Society of Great Britain has information about the demographics of people taking license exams in Great Britain. Age and gender data is available. Half of the exam candidates were between 40 and 59 years of age, and 95% were male. The reports are excellent, and like the other work presented, are available at the link in the slides. In prior work, we can see some clear indications of lopsided demographics in amateur radio. But is this homogeneity necessarily bad? Are there problems for minorities in U.S. amateur radio? Well, yes, there seems to be. I have co-authored 2 QEX articles with men. The tone and language of the mail received in reply to the articles published was negative, aggressive, and derogatory for me, and positive, supportive, and complimentary for my male co-authors. Exact same article, completely different response, both times. I've been assured, specifically in amateur radio context, that women just aren't interested in amateur radio, that women should be seen and not heard. I was silenced by a board member of ARDC. Good luck with that. Was told that a woman can't be above a man in a volunteer org chart at AMSAT because of what it says in the Bible. that white people are more focused and organized, and ham radio needs focus and organization, and any effort on my part to integrate, quote, the Browns are, quote, annoying. And I have been informed, as if I was remiss in my duties as a volunteer leader, that amateur radio just doesn't suffer any harm from being homogenous. This directly from the president of a major amateur radio organization. I've been told that technical teams composed of all white men from very similar backgrounds can simply work faster and better together, and that including people that look and think differently, like me, would just slow things down, and that's why I couldn't possibly be included. I've been told everything was fine until you showed up. I was advised if you just work quietly on tech and hand it over to your betters that you wouldn't get attacked, and I have been lectured that adopting a code of conduct means that the organization in question admits it has a problem, that everyone can just simply act like an adult, and that everything will be fine. In amateur radio, I've received death threats, rape threats, and obscene messages, all sent from a position of confidence that I do not belong in amateur radio, and will simply go away if people sending the messages are mean-spirited enough. Abuse like this is effective in chasing people off, and it's very, very rarely punished. The classes that these statements belong to are different experiences for the same work product, denial, shooting the messenger, different requirements from different people for the same job, selective enforcement with unspoken rules, and just simple attacks. Yes, these problems exist in amateur radio. They are real, and it's natural to wonder how demographics are involved. Do we need to be convinced that diverse teams and populations outperform homogeneous ones? Lucky for us, there's a pile of science. A good survey article from Harvard Business Review is linked in the slides. From that article, we can see that diverse teams are much more likely to price stocks correctly and to give results above industry mean. This is a very nice, free return on investment. Something close to my heart, since my primary focus is research and development for open source digital radio, is that, quote, gender diversity within R&D teams generates certain dynamics that foster novel solutions leading to radical innovation. The results indicate that gender diversity is positively related to radical innovation. However, it does not promote incremental innovation in the same way. So what is the solution for the lack of demographic data? With basic modeling, some demographics about U.S. amateur radio licensees can be constructed. Gender can be guessed based on machine learning models that assign gender to names. The ratio of men to women can be estimated, acknowledging that some names will be unknown, for example, Pat or Leslie. The databases used are geographically focused. For example, Japanese names in the US FCC database are not categorized very well by a US-centric machine learning algorithm. However, this can be done manually, or, for example, by rerunning Japanese names using a Japanese ML database. Race can be guessed based on probabilistic models that assign a race to a licensee based on census results per zip code or geotagging. Taking into account techniques from model thinking, we can refine this probabilistic model to include the effects of sorting and pure effects. The University of Michigan has the most public-facing presentation of this work. Age is more difficult to model because it has not been collected for U.S. licensees for quite a while, but there are some things that can be done. Look at the CW contesting work in the prior work section. Thank you to Marty Wall and Dick Norton for sharing a database of age information about amateur radio licensees up until the point it was no longer collected, and for providing a path forward for getting current demographics with respect to age. There have been some excellent suggestions, support, and advice that's been given, and work will continue in this direction. Knowing is better than not knowing. Amateur radio licensees are allowed the use of frequency spectrum because it is considered to provide positive public benefit. The amateur service in the U.S. is self-regulated. We need to ensure as equal access as possible. In practical terms, the responsibility for being of service to the general public is on us, not on the FCC. If we don't know our own demographics, we cannot authentically claim amateur radio is accessible to or of benefit to the general public. The FCC really could, and arguably should, be providing demographic information like it does for professional broadcasting licenses. An organization like ARRL could take this on and start to work with the FCC on better data. Data privacy is another area of discussion. Knowing removes any excuses for not dealing with it. This can be stressful and difficult work. The Python script written for this project can be found at the address in the slide. I'm going to walk through the code. It will be simplified, but I am not going to dumb it down. I'm going to speak about it and to you as if you were sitting at a desk managing paper files in order to come up with the results. My coding style can best be described as there appears to have been a struggle. I am not a professional software developer, although writing code is part of what I do at work. My formal background is information theory, which is an area of applied mathematics used in forward error correction, communications theory, compression, and cryptography. I have training in probability and statistics and additional formal training in writing and using models. With rare exceptions, when we sit down to solve any sort of problem, we don't do everything from scratch. When we do something like building a kit, we buy parts made in a factory and we follow a schematic designed by someone else. We quite often have to troubleshoot and test this kit, and it's really fun to modify or kit bash or decorate it. When we work on a car, we use tools that we bought maybe from Sears back in the day, and we follow along the Haynes manual, checking off the steps. But we consider the work done as ours. A lot of software programming is done the same way. In this section, we're bringing in some very useful hand tools. In Python, the language used here, we gather the pre-made blocks of code we're going to use with import statements. The command import is followed by the name of the module. We need to be able to move around in the directory structure on a computer and open files. We need to generate some random numbers. We're going to present the data in a web browser, and we're going to make some zip code maps. We are going to use something called pandas, which gives us a really neat structure called a data frame. This data structure bolts up to something called folium, which draws maps. These two modules work together. We import a machine learning tool for gender detection, and we import a zip code search engine that returns census data. Zip code in, data out. Now we're back at our desk. We create a custom set called active licenses. A set is a collection where the order doesn't matter. You won't need to edit the item after you add it, and there is no index. It's one of several built-in types in Python, and there's nothing in this set when we start out. It's empty. The code opens up files that we download directly from the FCC. This is from the downloadable databases page. One zip file has several files in it, and the one we start out with is hd.dat, or the header data file. In the yellow is a 4-line sample of what this file looks like. The code attempts to open the file. If it's not there, there's an error. It would be an improvement if the error message told you where to go to get the file, or better yet, just downloaded it for you. Once the file is open, it picks up the first line. Think of this as opening up a big binder of this file printed out and looking at each line. Each line is an entry of data about one U.S. license. We split up the line we're looking at on the vertical bars. This turns the single line into a list. We then take that list and we go to the 6th field, or the 5th field if you're counting from 0. That's where the 5 in square brackets comes in. Notice the field consists of a single letter. If that letter is A, then the call sign on that list is active. It can be expired or canceled, but we're looking for active licenses. We then move one field over, see the square bracket 4 element of our list, and that's the call sign. We put that value into the set that we made called active licenses. So if it has a letter A, we take up that call sign, put it in our set. The octothorpe or hash sign indicates a comment. In testing this code, I would print out the set of active licenses to make sure it was working. I keep those statements in here in case I need them again, but if you comment them out, they're not run when you run the program. After we've gone through the entire hd.dat file and set it down on our virtual desk, we have a set of active call signs. Next, we set up our gender detector. We are selecting the version trained on U.S. names. There are other options. We also set up our zip code database. This requires a download of U.S. Census data that is designed to work with this particular imported module. It should download the database the first time the code is run. We create a file called unknown names to catch the list of names that the categorizer could not figure out. Next, we set up a scratch pad for making our calculations and our counts. We then try and open the entity or en.dat file. This has full address information for all amateur radio entities. You can see what this file format looks like in the yellow highlight. Now that we have a list of active call signs, we can open the en.dat file and pick out addresses of active U.S. licensees, individual licensees. If we can open this file, then we go through it line by line. For each line, we separate the fields by busting up the single line on the vertical bars. If the call sign in this field is one we determine to be active, and if it's an individual license, then we go on. The first thing we do, if the line contains an active individual license holder, is take the zip code from that line and look it up in our zip code census database. Note the double square bracket trick to take only the 5-digit zip code. There are a lot of zip plus 4 entries in the FCC file, and the zip code census lookup does not accept this. We don't want to destroy any information, so we actually keep the zip plus 4 if that was the field. But when we do the lookup for demographic data, we just use the 5-digit zip code. If later on we add in another database with plus 4 data, we can take advantage of it. If this lookup fails to have data about population by race, we increment the zip code fail variable and skip over guessing the race of that particular licensee. Not every one of the 42,000 zip codes in the database has census data. We'll talk about this in the next steps. If it does have population by race data, then we calculate race ratios and make a probability table. If the zip code is, for example, 62% white, then 0.62 is calculated as the probability of being white. If it's 7% Native Alaskan, then it's 0.7. We use the census, 0.07. We use the census categories for making this table, and we use the results per zip code to generate the probabilities. All probabilities for a zip code better add up to 1. That's a rule of probability theory, a fact of census data, and it's how we found a bug in the code where we double counted a category and left another one out. Next, we generate a random number between 0 and 1. We look for which category that number falls into with some comparison statements. This is sort of like Plinko with probabilities, where the bottom of the game is marked up with the racial probabilities of a zip code instead of a payout. Once we get a result for that licensee from that zip code, we increment whatever category we ended up with in our electronic dice roll. Note that the results may be slightly different every time because we are generating random numbers and using a simple model of what race this licensee probably is based on the statistics of their zip code. This is a best case model. It ignores sorting and pure effect. It may be that in some zip codes, minority residents would never even consider sitting for a ham exam. It is a simple model. It gives us a starting point. What we would like to see is that the results come close to the racial distribution of the entire population of the United States. Now we want to make a map of where the hams are. We want to be efficient. We could list out all the zip codes and then put tick marks by the zip code of the active hams we find as we move through the entire en.dat file. But we're going to do better than that. We make something called a dictionary. It has a key and a value. Like a paper dictionary, you have the word, which is the key, and you have the definition, which is the value. You look things up by a key, and usually return the value as the information fetched. We have zip code as key, and the number of hams in that zip code as the value. For this dictionary, we are making at our desk. If we have a zip code we need to put a tally mark by, we first check to see if it's already in our dictionary. If it is, then we increment the value of hams by 1. If that zip code was not already in the dictionary, if it's a new one, then we set the value to 1. This means we have a dictionary with no gaps. Notice it's not stored to a file or anything like that. We're building it as we go in memory. So after we've made a guess about race based on zip code, we take the first name and we make a guess about gender. We're still working with the same line from the en.dat file, but now we pick up the name field. This means that even if there is no racial data, because that zip code doesn't have census data, we still look at gender. We have some quirks in this database that we're going to punch out or disregard. If we get no name, a comma as the name, a period as the name, or if we get this one weird Rust result with parentheses, then we don't run a gender detector test. Now, it's unusual these days to get a license application without a name or with oddball characters, but there are active individual licenses with non-word names. So what do? Well, we skip them. We take that name and we run it through a gender detector. This is a model created with machine learning and trained on U.S. names. It assigns either male or female or unknown. Names like Pat, Leslie, and so on fall into the unknown category. We write the unknown names to a file to make it easier to run more tests on them. We update our counts for gender, and then we print out all the counts. If the license was not an individual active license, which was our first real test, then we have skipped over all the tests. We come to this point in the code, and we simply put a tally mark in the other license type. Next, we make a heat map or choropleth. We have a completed dictionary of zip codes and tally marks for how many active individual licensees per zip code for the entire en.dat file. We convert that dictionary into something called a data frame, which can then bolt right up to the maps in the tool we imported at the beginning, which is called Folium. We make sure we put in some headings for our dictionary data frame thing we have made. The name of the column in our data must match the name of the column in the map we want Folium to use. We have lots of choices out there for map files. What I think we would really like to see is an interactive U.S. map. Now, we'll continue working towards that, and you are welcome to contribute. For today, we are going to build the state of California. I found a set of zip code maps for all the states of the U.S., and I learned how to use Folium, and I got it working. The tricky part is making sure that the zip code column in our data matches the column headings for the list of zip codes on the state map. Now, this sounds simple now, but getting it to work took more hours than I expected, and it wasn't obvious why it was failing. A choropleth is a heat map. It uses color value, light to dark, to indicate the number of items in a region. We set up the Folium map, tell it where to center and how far out to zoom, and then we tell it what colors to use and where our tally mark file can be found. We save this map as a web page called heatmap.html, and we open it in a web browser. Here we're using one of the tools we imported. Results. Here's the raw output from the gender detector. Very few were punched out. 14.5% were unknown. We jotted those down off to the side in a file, remember? Now, after looking at a random sample of those names and doing our best to track down the person online or on social media, the ratio of the unknown gender turned out to be the same as the ones the detector was more sure of. Assuming same ratio as known, we get 13.9% female and 86.1% male. So there's been no change in gender ratio for active U.S. individual licensees since 2005. If anything, there appears to be a slight decline. We see this also in professional engineering. The high water mark for women in professional engineering positions in the U.S. was around 1986. There is no significant difference in spot checks of very recent licensee batches. Here's the result from a recent Wednesday upload to the FCC. Census data dice roll for race results is in the following chart. Here's a close-up. Here's the census results by race using the 2021 model for the entire United States. Here they are side by side. Note the zip code fail category, and that 2 or more is about the same, that there are more white people, and in all other categories there are less. Do these models match what we see in our organizations and activities? Think about your local traditional ham radio club. Now, what I've done here is a best case model. It's a straightforward dice roll based on the racial makeup of the zip codes where ham lives. It's a best case. It does not take into account sorting or pure effect, but what happens if we do that? So first off, social science teaches us that small scale or micro motivations do not equal macro behavior. When you have racially segregated neighborhoods, can you then assume the residents are racist? Well, no, that's not what social science shows. The Schelling model is used to study the effects of segregation. It does not take a very strong preference for wanting to live near people that look like you, or walking into a ham club meeting and seeing no one that looks like you and not coming back, to create clearly segregated neighborhoods or clubs. If you use the Schelling model and you apply it to demographics where things are already lopsided, then the sorting effect means that small categories of people, like women or non-white people in ham radio, end up segregated into much smaller spaces, clubs, and organizations. If the demographics are really lopsided, then those organizations won't form in the first place because there's not enough people to provide enough officers for clubs to cover the U.S. They don't want to join a group where they feel like they are not welcome. There aren't enough of them on the ground to make a go at a viable alternative, so they quit, and they find something else to do with their time. The sorting effect is the individual choosing to associate with people that look like them. Peer effect is when you start to act and behave like the people you happen to be around. Think peer pressure, or, but it's tradition, or, well, we've always done it that way, why don't you? Everyone else does, so it must be fine. That sort of thing. Sorting can lead to discrimination through peer effect. Anyone acting differently becomes an existential threat and is stomped on until they leave. This is the connection between demographics and discrimination. The only way out of this is to enforce repercussions for bad behavior. That is a necessary condition for inclusion. Segregation is well studied in social science. Once you model sorting in pure effect, then small minorities tend to disappear or drop out at a much higher rate than majority members. Whether they are leaving because they were made to feel unwanted, harassed because they were not a peer and pure effect bonding needs are strong, or just because they didn't feel comfortable being around people that don't look like they do, and they removed themselves as fast as they could, the results match what most of us observe in amateur radio. It is almost all men, and they are almost all white, especially in the traditional amateur radio club scene, where they are almost all old and disproportionately wealthy. Look at the board members of most any major U.S. ham organization. They're older, white, wealthy men. Now, there are exceptions. There are diverse ad hoc and interdisciplinary technical groups in amateur radio or amateur radio-related fields. The nonprofit I founded and work for now has a 60% underrepresented board membership, and it has a very racially and age-diverse technical team. It is mostly men on the volunteer teams, but since we do FPGA and VHF communications designs and microwave designs, this isn't really too surprising. Another example, my local DEF CON group has a lot of hams, and they're like me. This is one of the places hams go when they don't feel like they fit in with the local San Diego repeater clubs. The DEF CON group is growing, has at least a program presentation a month, lots of mutual aid, and it's informal. There aren't any bylaws, there's no dues, but it has a code of conduct and high expectations for good behavior. It's about 30% women at the meetings and has a pretty good racial diversity. The local repeater club is almost completely white male dominated. It's a formal 501c3. It has membership that's been shrinking steadily since the 1980s, and it's struggled hard to fill the officer positions every election. It no longer does its own field day. And I can't help but draw comparisons between these two communities. The amateur radio service does have an obligation to be of real public and educational service to the general public. So what do we do about this? Well, let's look at the maps and ask some questions. Here's the state map we generated with our code. The very dark zip codes have 0 entries. There are also missing zip codes. You can see some of the disadvantages working directly with zip codes and not yet converting to proper geotagging. Zip code data is quick but dirty. There is a solution, and it's to spend time replacing the zip code lookup with a more direct census data lookup. The advantage of the zip code census data? It's free. So what can we do with this data? Well, where does Park meet for club meetings? Park is Palomar Amateur Radio Club, one of my local clubs. It meets in Carlsbad. Where are the hams? Well, they're in Poway, Ramona, Encinitas, Carmel Valley, Claremont, Mira Mesa, Encinitas, Lakeside, and Santee. Carlsbad doesn't have a whole lot of hams. Should the club consider another location for meetings? Well, what if those areas already have a local club? With data, you can ask these sorts of questions. On this map, what is up with Yucaipa? Hey, what's the story on Placerville? Here's San Francisco. Notice where the hams are. Next steps. Can we get the FCC to directly provide demographic information? Preferably with more privacy and not less. Can we get demographics without someone like me handling your data? Address the shortcomings of using zip codes by using proper geotagging. Continue to refine and expand the demographic models to extract more data and more value. Make an interactive map of the United States, not just California. And speak up about things in amateur radio that filter people in or out. Make the local changes. Be prepared to look at things that club leadership tends to take for granted. For example, we might think reciting the Pledge of Allegiance at the beginning of ham club meetings is not a problem. But for a large fraction of young people, it is something they bring up as a very big turnoff. Young people will sort themselves right out of ham radio well before you get any chance to force them to appreciate reciting the pledge through pure effect. This is an open source project, meaning you should be able to recreate everything I have done based on the published code. Pull requests, forks, questions, improvements, and contributions are all welcome. You can reach me at Whiskey 5 November Yankee Victor or W5NYV at arrl.net.